AP Calc BC kids, here we go with arc length with parametric equations. It actually comes off of the same formula that you learned back when we were doing arc lengths for curves in the rectangular form. But here's the parametric form. It's going to be the same thing, but here's what it actually comes out to be. I'm not going to give you the full throttle of this. If you look at the curriculum video from Flip Math, they'll do the whole derivation of where this comes from. But in our case, remember, we're doing parametrics. So our f prime of x is actually, we call it dy over dx. And we square it. And that's with respect to x. If you take that and you adapt it, you get common denominators, you're going to get a complex fraction, and then you end up working your way through this whole thing. It ends up to be that for parametrics, it adapts into this formula. The integral from a to b of the big old square root of dx over dt squared plus dy over dt squared dt with respect to t. And again, you can go and watch the curriculum video and they'll give you the derivation of where that comes from. And I think if you remember in section 9.1, they actually gave you an equation where they said, find this, without the dt, find this, evaluate that. And we were like, okay, we can do that. Now they did that so that kind of we're giving an introduction into this particular section. So all we need to do is figure out what the derivative of the x equation is in the parametric, square it, add it with the derivative of the y equation, square it, and then take the square root. So that's the plan for each of these questions. Number one, this one's going to be hopefully a relatively short video. I want to know what x prime of t is. Well, the derivative of cosine is negative sine. And I need to know what y prime of t is. Well, the derivative of y is sine, so cosine of t. And so what I'm then going to do is put it into my formula right here. I'm taking the x prime of t and the y prime of t and plugging it in. And they're telling me I'm going between 0 and 2 pi. There's my bounds, 0 and 2 pi. I have a big old square root, negative sine of t squared plus cosine of t squared dt. We're going to clean it up just a little bit. The integral 0 to 2 pi gives me negative sine of t squared is a sine squared t. This is cosine squared t dt. What do we remember that that's equivalent to? Bells should be going off. Woohoo! Sine squared plus cosine squared is 1. Integral from 0 to 2 pi of the square root of 1, which is 1, dt. Now I can take the integral of that. What's the integral of 1? The integral of 1 is t, and I want to evaluate that going between 0 and 2 pi. So you literally take the integral, then you evaluate it. It's going to be 2 pi minus 0, f of b minus f of a. My answer is 2 pi. Okay, same thing. Got to do it over here. Find, for each set of parametric equations, find the length of the curve. So I'm going now between 0 and 2, and I need to know what my x prime of t is, and I need to know what my y prime of t is so I can put it in. This would be negative 4. This guy would be 7. Now that's interesting, right? L equals the integral from 0 to 2, bounds are in your inequality, of square root of negative 4 squared plus 7 squared with respect to t. 0 to 2 is my integral. Square root is 16, 4 squared. 7 squared is 49. Combine them together. It's a lot of writing. Square root of 65. Well, if I think about what the integral of the square root of 65 is, it's like a constant. So I just have to add a t onto that. So it's going to be the square root of 65 t going from 0 to 2. So I have 2 square roots of 65, right? Minus 0 square roots of 65 leaves me with 2 square roots of 65. And that's my final answer. Oop, I lost you. There it is. So guess what? That's the only examples that they give for this particular section. So I picked 2 that got a little bit interesting. I thought might cause you a little bit of grief on the practice problems. First one I picked is number 2. It says, I picked this one because it's got the A's and B's in it. You know how we love those so much, right? X is a over 2 t squared and y is b over 2 t squared, where a and b are constants. What's the length of the curve from 0 to 1? Now this is going to give you an answer that is in terms of a's and b's, and that's okay. You just that there are constants in the midst, so don't be alarmed by that. But let's get our 2 equations, x prime and y prime. Now remember, this is a constant, so the 2 comes down in front. A over 2 times 2, cancel the 2's and leaves me with an AT. A times t. The same thing's going to happen over here. 2 is going to come down in front, cancel with the 2, and leave me with a BT. All right, let's go. L equals the integral from 0 to 1 of the square root of AT squared plus BT squared with respect to t. And there's not a whole lot I can do with this, but let's just play a little bit. 0 to 1, I would have a square root of, let me do it this way, a squared t squared plus b squared t squared. And what do you notice they both have that I can factor out? I can factor out a t squared, right? So I'm going to have L equals the integral from 0 to 1 of the square root of t squared, and that's going to leave me with, oh, not square rooted, parenthesis, hang on, a squared plus b squared. Well, can I take the square root of t squared, and what would it be? Because it's factored out, it's a singleton piece. It's going to be, remember I'm trying to get to an integral here, so it's going to be the, if I take that t out, it's going to be the integral from 0 to 1 still. But it's going to be a t on the outside and a square root of a squared plus b squared on the inside. When I go to integrate, remember a and b are variables that represent constants. The only real variable I have is t. And so if I take the integral of t, that would be like t to the 1 more power divided by the power. So this would be, if I take the integral, it's going to be t squared, t to 1 more power, divided by the power, so that's like 1/2 t squared. And then a squared plus b squared, they're your constants, so that doesn't change. So now you've integrated, and you're going from 0 to 1. Well, if I put in a 1 squared, and remember the variable that I'm talking about is just t. A and b are constants. T, so t squared is 1. 1 squared is 1. 1 times 1/2 gives me 1/2. This is my f of b part. 1/2 of the square root of a squared plus b squared minus f of a. If I put a 0 in here, it's 0 times that square root, so it all is just a 0. And so your final answer for this guy is 1/2 the square root of a squared plus b squared. Now that one's a little odd because it's got all these different variables in it, but really the only real variable is t. A's and b's are constant. And that's number 2. The next one I wanted to show you, and this is the last one, is number 3, and you'll see why I chose this one in just a minute. So it's the same thing. It says find the length of the curve. You've got your 2 equations between 1 and 4, and you're like, yeah, why would you choose that one? That one doesn't seem so bad. It's not terrible. It's just a little bad. All right. Derivative of your x term is a 4t. Derivative of your y is a, 3 comes down, gives me a 2t squared. Put it in your formula for arc length. Integral goes 1 to 4. X is 4t, square that. Y prime is 2t squared, square that. See if you can make it any better. Let's see. It's 1 to 4, not 0 to 4. 1 to 4. I am square rooting. 4 squared is 16t squared. This is a 4t to the 4th. And so looking at those pieces, I keep wanting to put 0. Looking at those pieces, what can I factor out of that? And so 16t squared, 4t to the 4th, I can take out a 4t squared. What will that leave me with? And we say 4 plus t squared. Oh, forgot my dt's. Fix that. Mr. AP would take off points. Still looking at it. I haven't integrated yet. Just still looking at cleaning this thing up. I have a 1 to 4. The square root of 4t squared would be a 2t on the outside. But I still have a 4 plus t squared on the inside. That is with respect to t that I'm supposed to now integrate. Well, guess what? This is for my dear friend Maddie, who loves u substitution so much. So you have to, the only way to integrate this is to u sub. And so I'm going to let u equal what's inside the root, 4 plus t squared. Means that du equals 2t dt. Do you see how this is going to line up kind of pretty? It all is fitting into place. But my bounds also change. My bounds change based off of my u equation. So if I put a 4 in here, 4 plus 4 squared is 20. Upper bound's 20. 4 plus 1 squared is 5. So I have new bounds based off of that. Let me see if I can put it together. All right, so I haven't integrated yet. I'm still trying to get there. My L is now bounds of 5 to 20. I have a u that's being square rooted, so u to the 1/2. Du is 2t dt, so that's good. So this is now my du. And now I can do my integral. So if I have a u to the 1/2, it's u to 1 more power, u to the 3/2 divided by 3/2 means it's times a 2/3, and that's going between 5 and 20. Woo, then it's just a matter of evaluating it. So let's see, I've got 2/3 on the outside. I have 20, if I put a 20 in here, 20 to the 3/2. So I'm going to have 20 to the 3/2. I'll leave it that way. If I put a 5 in, I've got 5 to the 3/2. 2/3 is on the outside. It's the inside that gets messy. Now think about this for a second. If it's the square root of 20 3 times. The square root of 20, square root of 20, square root of 20. I'm going to have 20 square roots of 20. And if I do the same thing with the 5, it's the square root of 5 3 times. So it is 5 square roots of 5. Well, guess what? This guy here, the square root of 20, the square root of 20 is like 4 times 5, 2 square roots of 5. Creates this, I still have the 2/3 on the outside. 2 times 2 is 40 square roots of 5 minus 5 square roots of 5 gives me 2/3. Leave my paper over here, I'm going to lose you. 2/3 times, where am I, 35 square roots of 5. And I am almost done, children. It is 70, 35 times 2, thirds, square roots of 5. That, I don't want to box it, but that, my friends, is your final answer for number 3. That one got a little goofy. I think it's the only one that requires you to go into a U substitution to be able to calculate out what that integral is. The rest of them are pretty straightforward integrals. So have at it. Your problems are 1 through 10 of the practice, and shoot me an email if you've got questions. I'll see you in class.